Planet Earth, the third planet of the solar system. For thousands of years, mankind has explored this world, seeking answers to their biggest questions. This curiosity has guided them from discovering other planets through a telescope to leaving Earth may be a wasted effort. The truth of the matter is, space exploration is a necessary endeavor. Why are we here? Where did we come from? People would try to explain why the universe is the way it is by looking for answers in the stars. One of the earliest influential astronomers was the Greek philosopher Thales of Miletus from the 6th century BC. Thales is often credited with creating the foundation for modern mathematics and philosophy. He wanted to explain nature without referencing mythology. He believed the world was a floating disk in a heavenly ocean surrounded by a sphere of stars. Aristotle was a notable astronomer from the 3rd century BC. He popularized the idea of a geocentric world in which the Earth is the center of the universe and the Sun and other planets revolve around it. Although we know today that the geocentric world is incorrect, it was preferred because it furnished a plausible explanation for gravity, assuming the Earth had the ability to attract all matter to its center. One of the most important scientific publications ever made was On the Revolutions of the Celestial Orbs by Nicholas Copernicus. He claimed that the Sun was the true center of the universe and the Earth was just one of the planets orbiting the Sun. Copernicus delayed publishing his work until his deathbed due to a growing controversy, not just with the Catholic Church, but with the scientific community who was a new concept after hundreds of years. Copernicus's ideas and was the first to use one to look at the stars. Galileo showed how the other planets have their own satellites and orbital phases just like our moon. Unfortunately, the church convicted him of heresy and imprisoned him in his home. Today, however, Galileo is recognized as the father of physics and modern science. Mankind has been fascinated with flight since prehistoric times. Before the Middle Ages, people were able to fly kites and release sky lanterns. They understood how warm air rises, but did not have a complete grasp on the physics. In the late 1400s, the painter, astronomer, and inventor known as Leonardo da Vinci created his own designs for possible flying machines. While the designs were ahead of their time, they did not fare well when practically tested. It was not until the late 1600s, when Isaac Newton developed calculus and his 3 laws of motion, that inventors began to understand the way machines had to work with the air to escape gravity. In 1783, Jacques Charles and the Robert brothers successfully launched their manned hydrogen balloon and ascended 1,800 feet into the air. A crowd of 400,000 people watched in awe as the brave scientists risked their lives to make history. America's own Benjamin Franklin was one of the spectators who witnessed the event. Balloons became useful for scouting the battlefield during wartime. The technology proved human flight was not impossible, but it lacked an effective way to steer the balloon's direction. The technology would continue to develop over the next few decades into what are commonly known as Zeppelins. Named after Ferdinand von Zeppelin, the giant airships first took to the sky in October 1900. Germany took immense pride in the Zeppelin despite a few failed experiments. Huge donations from the public helped Ferdinand found the Zeppelin Foundation. By 1909, Count Zeppelin had started the world's first airline. Airships had shown their commercial and battlefield capabilities, but airplanes were struggling to take off. Building on top of the gliders designed by Sir George Cayley, the illustrious Wright brothers experimented with different control methods. They eventually found success in 1903 with adding gasoline engines and a propeller to the biplane. Orville and Wilbur's greatest contribution to flight was the 3-axis control, which is still used on all winged aircraft today. In 1907, they found themselves trying to negotiate military contracts to sell their flying machines to the American and European governments. Shortly after that, Airships and airplanes made their debut on the battlefield in World War I. Mankind had taken to the skies, but there remained greater uncharted territory further above. In the late 1800s, the birth of science fiction stories such as The War of the Worlds by H.G. Wells opened the minds of thousands of readers to the possibility of space exploration. The world's curiosity continued to grow as the edge of space drew nearer every day. One man by the name of Robert Goddard made a great contribution to mankind's ascension. He spent many years studying and working with rocket propulsion. Though rockets had been used as weapons for centuries, Goddard sought to use them to break through the Earth's atmosphere. Earlier, he designed rocket launchers and torpedoes that were used in World War I. After the war, Goddard succeeded in launching the world's first liquid-fueled rocket in 1926. While he did not receive much support from the public at the time, today he is seen as the founding father of modern rocketry and the man who ushered in the space age. On the European side of the story, there was Wernher von Braun, an ambitious German engineer who was set on building rockets for the sole purpose of reaching space. Braun was the leading engineer in Nazi Germany's V2 project. The V2 was the world's first intercontinental ballistic missile that was to be used on the Allies during World War II. The V2 became the first man-made object to enter space in October 1942. After the war, hundreds of German scientists and engineers were brought to the United States through a program known as Operation Paperclip. Von Braun and more than 100 members of his team were brought over. The team began working for the United States on reconstructing and launching captured V2 rockets. Wernher remained committed to space exploration even when designing missiles for the Army's Redstone Ballistic Missile Agency, well before joining NASA in 1960. He helped popularize spaceflight by joining Walt Disney in the Tomorrowland television series on space. Progress in space technology that pushed the country from the Industrial Revolution to the space age came with a price: the development of the destructive weapons of the Cold War. After joining the United States to help defeat the Germans in World War II, Joseph Stalin split the Soviet Union from the Allies and began a massive weapons buildup. Stalin was interested in building nuclear missiles and began a missile program using captured V2 rockets like the United States. The V2 program would advance both countries towards competing space programs. Wernher von Braun's missile design team would be pitted against the Soviet team led by Sergei Korolev. Because of his rocket expertise and participation in the 1946 V2 recovery effort, Sergei Korolev was appointed head of the new Soviet Missile Design Bureau named OKB-1. His first project was constructing copies of the V2 using only Russian components. The Soviet copy became the R-7, their first intercontinental ballistic missile. Korolev was interested in using the missile to place a satellite in orbit, and had the project approved. The satellite launch offered an opportunity for the Soviet scientific community to prove their level of theory and technology. On October 4, 1957, the K-7 launched Sputnik 1 into space. The satellite was the first successful orbital launch. It circled the Earth once every 94 minutes, traveling at 18,000 miles per hour. This paranoia fueled the space race. At the time, the United States was surprised by how much the Soviet space program had advanced. The American public was made well aware that the Russians had long-range nuclear capabilities. The Navy's efforts to build a satellite were unsuccessful, so they turned to von Braun's team in the US military. After the success of Sputnik 2, President Eisenhower charged the military to do whatever it took to put a satellite in space. On January 1, 1958, the National Aeronautics and Space Administration, or NASA, was formed. By the end of that month, they succeeded in launching the Explorer 1 into orbit. In 1961, President Kennedy said America would succeed in landing a man on the moon and returning him safely to the Earth by the end of the decade. It sounded like science fiction, but the American spirit received a great boost from Kennedy's claim. Mercury Redstone was the first mission of NASA's Mercury program. In May of 1961, Alan Shepard, pilot of the Freedom 7, became the first American in space. While it did not achieve orbit, it did enter space, thus the mission was labeled a success. Meanwhile, the Soviet Union successfully carried out the first human spaceflight mission, in which 27-year-old Yuri Gagarin piloted the Vostok 1 and completed one full orbit around the globe. This mission was secretly done approximately 3 weeks before the United States Mercury Redstone. Once again, the Soviet Union was one step ahead of the Americans. The race to the moon was beginning to pick up speed. On September of 1963, at the United Nations General Assembly, President Kennedy proposed that the United States and the Soviet Union join forces in their efforts to reach the moon. The Russians were inclined to accept this offer, but changed their minds after Kennedy's assassination in November of '63. 1 week after, President Johnson would begin the Gemini and Apollo programs, promoting them as Kennedy's legacy to the public. The Soviet Union continued to push further ahead of the United States. They had already reached the moon when their unmanned spacecraft, the Luna 2, crash-landed in 1959. It was only a matter of safely getting humans there and back again. The Americans began their ambitious plans for Project Gemini, while the Russians were working on their Voskhod program. The two projects had similar goals, launching more advanced spacecrafts that were capable of changing orbits, docking onto other spacecrafts, and allowed for extravehicular activity. The Gemini missions provided extensive experience for the future Apollo pilots. In 1967, the United Nations created the Treaty on Principles Governing the Activities of States in the Exploration and Use of Outer Space, including the Moon and other celestial bodies, better known as the Outer Space Treaty, which was signed by both the USSR and the USA. The treaty banned countries from storing or testing weapons in space or on the moon, and declared that the exploration of space was to benefit all countries. It also forbid any government from claiming the moon or a planet, as they belong to all of mankind. It was a considerable step forward in making space exploration a peaceful journey in which all countries could partake. After many successes with their previous Apollo missions, NASA was ready to take the giant leap. On July 16, 1969, the Saturn V rocket launched from the Kennedy Space Center in Merritt Island, Florida. The astronauts traveled for 3 days until they reached lunar orbit. The space race reached its dramatic climax on July 20th when Buzz Aldrin and Neil Armstrong landed the lunar module on the moon. The event was being broadcast to the entire world. 700 million people watched as the two astronauts stepped out onto the lunar surface and raised the American flag. As Armstrong put it, it was one small step for man, one giant leap for mankind. They spent 2.5 hours outside the spacecraft, taking photos and collecting 47 pounds of moon rock to take back to Earth. The third member of the mission, Michael Collins, piloted the spacecraft in lunar orbit until Aldrin and Armstrong returned in just under 22 hours for the trip back to Earth. The team landed safely in the Pacific Ocean on July 24th. Kennedy's promise of putting a man on the moon before the end of the decade was accomplished with 161 days to spare. The race began to slow down after the completion of Apollo 11. The Soviet Union was facing numerous complications with their moon programs, and eventually canceled them after 2 more launch failures in 1972. NASA was not without their own problems. The very first Apollo mission in 1967 ended when a fire erupted during a launch pad test, killing the 3 astronauts on board. In 1970, the Apollo 13 mission took a disastrous turn when the spacecraft's liquid oxygen tank burst. The 3 astronauts on board survived and returned to the Earth safely, but the program was grounded for a few months. NASA had to put their ambitious plans for a 1986 manned flight to Mars on hold. One of the greatest tragedies to ever befall the country occurred in January 1986, when the Space Shuttle Challenger exploded over Florida just seconds after takeoff. 7 brave crew members lost their lives, and the manned space program was dealt a nearly mortal blow. The disaster prompted the space program administrators to develop new plans for the space shuttle construction and better safety controls. A similar fate befell the Columbia shuttle in February of 2003. The wings were damaged during launch, and the shuttle broke apart during re-entry. 7 astronauts were killed as debris rained down over Texas and Louisiana. The exploration of space was proving to be a very dangerous endeavor. The increasing number of men who lost their lives in spaceflight could not be ignored by the public. Some citizens see this and believe space exploration is needlessly unsafe for the pilots and a poor use of government funding. The loss of life is always unfortunate, but the reality of the matter is space exploration is necessary. The number of ways it has enhanced our everyday lives is innumerable. New technology we have gotten from research done by space agencies such as NASA include MRIs, convection ovens, improved artificial limbs, home insulation, carbon monoxide detectors, improved airline engines, infrared cameras, radial tires, laser heart surgery, satellite television transmissions, ultrasound scanners, and solar-powered technologies. Economic analysis of the NASA programs often show economic benefits, generating many times the revenue of the cost of the programs. Despite its incidents, most of the public remains supportive of space exploration. According to an Associated Press poll, 71% of US citizens agree that the space program is a good investment, compared to the 21% who do not. Perhaps the most important benefit of all is that space programs help inspire students to study in science and engineering. What is arguably one of the greatest reasons why space exploration must continue is because staying on Earth could lead to extinction. What might seem today to be only a possibility for the distant future could someday be a stark reality. The world does not have the natural resources to last forever, and nuclear wars could render the planet uninhabitable. The theoretical physicist Stephen Hawking believes the human race will not survive unless we spread into space. There are too many accidents that could befall life on a single planet. Even if it must happen slowly over centuries, it is imperative that humanity develops the technology to leave the Earth behind. NASA has already begun interstellar exploration. In 1977, they launched the space probe Voyager 1, which has been sailing away from the Earth ever since. It has passed by and taken photos of all the other planets, and as of August 2012, the probe has exited the solar system. The Voyager has become the farthest man-made object from the Earth, and the only one in interstellar space, 20 billion kilometers away, or about 20 light hours. The Voyager is carrying the Golden Record, a disk holding photos and sounds of Earth and its life forms, just in case the Voyager is ever found by intelligent life forms from other systems. In 1998, the United States and Russia worked together to launch the International Space Station. It is the largest satellite in orbit and can be seen by the naked eye from Earth. It serves as a laboratory for conducting biology and physics experiments and testing equipment for future use in Moon and Mars missions. Space colonies are still more of a dream for the future, but progress in making space access easier is happening every day. Potential sites for space colonies include the Moon, Mars, asteroids, and free-floating space habitats. NASA is making plans to have humans on Mars by 2030. Just like the Apollo missions, the trip to Mars will be for the benefit of all humanity. But this time, we plan to stay there. NASA is currently gathering information from experiments on the International Space Station, so crews can live in deep space without harm from radiation and the effects of microgravity. Recent discoveries from the Mars rover Curiosity have shown that flowing salt water, which could sustain life, is likely flowing on Mars. It also contains remains of ancient lakes and riverbeds. According to NASA Administrator Charles Bolden, NASA is closer to sending American astronauts to Mars than at any point in our history. The history of space exploration is an enduring story of brilliant scientists, a history spanning hundreds of generations. Since antiquity, scientists and inventors have inspired students to research and become inventors themselves. Today, technology is constantly evolving at a rate unlike the world has ever seen before. It is well within the realm of possibility that we could see commercial space flights in our lifetimes. Any of the students around you today could be the ones to give NASA the push it needs to take the next giant leap. The story of space exploration is constantly being written, and this could be just the beginning.